That is awesome.
Well, I've started recording. You can do it.
Okay.
Do you really want to get into this?
I think we can get started.
How I am right now?
Unless.
Wow.
So are you guys here for Arduinos?
They are.
They are?
Your hand is so warm. Why is your hand so warm? Sweaty. You're sweaty. It's warm. Yeah, we're too warm. Oh my god. This is so hot. Ah. Oh, I know you are. It's your personality, so sunny. One person in the corner, like I do. I did things like that. Yeah, right. Yeah. No, I need to go babysit my room. I'm a working mom.
So these are handful of stuff. And then okay, that's good enough.
Is it very beginner?
If you know how to spell it, that's all you need.
No, I meant I said it's very beginner.
Yeah, oh, this, we're gonna start out at the very beginning and then we're gonna move really fast to try some of these fancy other stuff.
Oh, okay.
And if you're a ringer, then you can help.
I'm not really a ringer, but I am familiar with that.
I'm probably the closest you can get.
Okay,
I'll do my best.
yeah, sure, we'll, when we get started. we can-
Oh, don't worry.
So what I need to get?
Oh, so it looks like we're grabbing a red board right now in Cyber People's era.
Anything you want, I mean, you'll come back and get what you need once you figure out what you want to do. Yeah. Those are MOSFETs.
Do you guys have adapters?
For what?
Because I don't have a USB on my computer.
You see, I can let you one. I say that because this is the third one that I've had to get.
Thank you.
So, thanks. Happy to be here.
Who's in it?
Yeah. You know what? Should be good. Let's see how I how.
What about we got a red board and then maybe a USB mini?
Hi.
I saw your name on the thing, so I just thought I'd stop by and say hi.
Are you gonna join us?
You
And then you might.
You know I should be doing subtitles.
Where did you see my name?
On the website.
I'm not done with the song.
Oh, the T9 website? Oh, are you gonna do?
Well, so basically it was this hackathon challenge. So there's a NASA challenge, which is a remote sensing data.
Yeah.
And I haven't actually looked at anything stuff. So I thought, just walking in.
So there's a lot
a little bit more fun with it. So, and also because if I use this as an excuse to do it, I would not do it beyond. And therefore I
Yeah,
can't.
you're right, you're right.
Yeah, that's the red
So
board.
I can't find with finding that nobody, so I'll just sit up.
It's like a red board along with you.
We're gonna do flash mice and Arduinos.
With it, I saw the.
Yeah. We got some cool.
How you doing?
Great, yeah. Very busy semester. Yeah, yeah, busy too.
So I thought this semester I stopped systems.
Yeah, yeah, we did. I gotta get started here.
I would talk to you about.
Yeah, can we just sit by our office?
Yeah, definitely. Yeah.
Oh, do you want to sit over here?
Okay, so. How's it going? Everybody's got an Arduino? And if you don't, find a friend that has one.
Chris over here.
Do you need a cable? Okay, who else uses an Arduino? Okay. So, is there maybe an Arduino? Okay, so here's what we're gonna do. How many of you have never touched an Arduino before? Oh my, okay, good deal. How many, you guys have never used an Arduino, have you done any coding at all?
Yes.
Okay, good. An Arduino uses a dumbed down version of C++. So if you know C++, it's a very similar. Okay. An Arduino is what we refer to as a microcontroller. It's different from a microprocessor. Microcontroller is typically embedded and hidden into something, and it runs code that you type into it. And once you enter the code in it, it just stands there running things. And so we're going to write the code on our computer, and then we're going to upload it to the microcontroller. Really, really simple. And the only thing we're going to do today is we're going to flash different kinds of lights. And I brought 3 different kinds of examples of LEDs that we're going to drive. Let's see. So up here, this is my Arduino. Get it plugged into the computer. And the first thing, the absolute easiest thing there is to do is direct drive an LED. And as many LEDs as you can plug in there, you can drive independently. You can make different colors. You can flash different patterns, all that kind of stuff. Really, really, really simple. And you can see a flash in it. The second kind of LED we've got is a smart LED. And that is these strings of LEDs. And if you want to, I'll show you how they work. If you want to use them, you can cut it to length. There's, it's like every 2 inches, there's another LED. And they're all digitally programmed. And so you can use any length you want. Because they're really small and really flexible, they're called fairy lights. Because you can, wrap them around and integrate them in clothing. You laugh, but that's what people do. They put it in their clothing because they're really flexible. They and we can program it with different lights, and I'll show you what we can do with that. So we're going to do some hardware to connect them in to the Arduino, and then we're not going to really write any code. I'm going to show you where you can download some of the simple code and then just modify it a little bit if you need. So I'm going to drive this guy, and I only have 4 LEDs on this guy, and so we're only going to drive 4 of them, and still uploading. Here we go. And so let's see. Can we see those guys? So I have a pattern running here that there are 4 LEDs. Each one can be a red, a blue, and a green. And each one, we can control the brightness of it to 8-bit resolution. And how many different levels do you have in 8-bit? Levels are there? Yeah, well, 2 to the 8th, so 256. You start at 0, so 255 levels. And each LED, red, green, and blue, we can control to 255 different levels. And if you get a certain brightness of a red and a certain brightness of a green and a certain brightness of a blue, you can make any color. And so each one is 8 bits, and we have 3 different colors. And so altogether that's 24-bit, and we call that 24-bit color. And so each one of these LEDs can show 2 to the 24 minus 1 colors. And you know how many that is? 16 million. So if you can decide what color you want, you can program each one of these independently with that color, and you can make all these patterns, and they're flashing, and they're really cool. So that's the second kind of light that we're going to drive, is smart LED, and we're going to send information down it and tell each LED to turn on the color that we set and when to turn off and then turn on. We can make patterns and all sorts of things. Okay, so that's the second one. And now the third one is, you say, well, this isn't very bright. Make it a little bit brighter, but there's some limits to it. But if you really want bright, you want intense color, then we've got these other LED strips that are individual red, green, blue. And the same kind of thing, we can adjust the color the brightness and the color we end up with by turning the red, green, blue on different brightness levels. But the difference is they're all connected in parallel. That means whatever you do with one, all of them are going to do that. But I'm going to show you how bright it is. So we have these strips, and you cut it to the number of LEDs that you want. So let's drive that one. So I put this one on. I'm only driving one of the colors, and so I've got the code. I'm uploading it to the Arduino, and the Arduino is driving the. So is that like the brightest green that you've ever seen? Now that's just the green. Let's see. It's got, here's a blue. Now let's see if I get the right plug in there. There it is. There's the blue, incredibly intense. And then here's a red. And so you're going to be able to drive them. You drive each of the colors separately, different intensities, and then you can make any color by the combination. Only downside is every one of the LEDs is going to be the same color. And you can cut the strip to whatever length you want, depending on how big a thing you want to light up. Okay, so those are the three different light shows that you're going to create. I'm going to walk you through really briefly how to set up the code. And okay, so we're going to finish at 10. I'm going to go home and go to sleep tonight. I'm not going to be around. So you guys are going to be on your own. And so I don't want to just show you do this, do that. I'm going to show you a couple websites that we're going to walk through really briefly. So you can go back there and follow through in more detail if I'm not here and you're trying to figure out what's what. Okay, so we're going to do the very first one for those of you that aren't familiar with Arduinos to kind of get started. So everybody that wants to play has an Arduino, and everybody that wants to play has an Arduino and a computer. Okay. Or you can work with your buddy and you can work together, or you can get your own laptop. So after I show you how to do all these things, if you want to integrate any of these in your projects, we have plenty of extra stuff over there. So you can grab however long the length of the smart LEDs or the bright LEDs, or you can grab the individual LEDs, we've got plenty of them. And we've got the Arduinos, and we've got the cables and all that stuff. And so you can integrate them however you want to in your projects. Okay, so we're going to start out with the absolute simplest within Arduino. So let's see, for those of you that have used Arduinos, do you have the way we program Arduino is with the integrated development environment, the IDE. How many of you have the IDE on your computer? Okay, you don't. Who else does not have? I should have asked who does. You don't have it. Okay, so here's what you're going to open up your computer, you're going to turn it on, and you're going to go to a browser, and you're going to download. So you go to the browser here, and I'm going to open up a new tab, and you're going to go to Arduino. That's why I said, if you can spell it, you can do it. Arduino.cc. So here's the Arduino website. And if you go to software, at the very top here, you're going to see, hey, here's the latest IDE. You're going to come over here, download options. And I don't know, do any of you have not a Windows system? Anything other than Windows? Y'all have Windows? Okay, that makes it easy. So you're going to come over here and you're going to grab the Windows 7. I'm actually on 11. How many of you have 11? Nobody? I'm the only one? Oh, you have 11? Okay, I was going to say, if you have the choice of switching from 10 to 11, don't. Stay with 10. Windows 11, I think that, yes, terrible system.
You always have to wait 6 months or a year for all of the big companies' IT departments to find all the bugs.
Yeah.
Before it's worth switching.
So I had a 10 machine, and Windows in the infinite wisdom decided they would just upgrade me anyway. They didn't give me a choice.
Nice.
Can you not go back?
I would be more scared of going back than continuing with 11.
Okay, fair enough.
Okay, so when you get here, you say contribute. Yeah, you can donate if you want, but wait until you're a pro at it. So just say download, and then you'll download the IDE, and then you can install it on your computer. Okay, so everybody needs to get the IDE on their computer. and you double click, install it and all that stuff. And then I'm going to show you how we get started with it. So let's see. So let me know, maybe raise your hand when you've got the Arduino IDE installed and you're ready to go. You're ready? You're ready? You're ready? We'll give it a minute here. The hard part of programming Arduino is making sure your computer has the driver to talk to the Arduino. If we can get that far, everything else is downhill and easy from there. So if you've installed it, you'll get a little icon to run it, and I'm just going to open up the default Arduino, and it's going to come up with a blank screen. And so here's the blank screen that it's going to come up with. So let's see, audio settings, I don't care about that. So when you're here, raise your hand, and that way I can get a feel for where we're at. And if you need help, we get a couple of ringers here that will help you. Anybody need help? A minute to install. You have a Mac.
I do.
So when you download the Arduino IDE, download that Mac version.
I did.
Oh,
It's
okay.
all set.
Okay. Are you here yet?
Yeah. I'm on this.
Oh, fantastic. Okay, everybody's okay. Anybody not here?
So I'm a little nervous.
Okay, so we got everybody at this point. Okay, here's the most important thing you have to do. Your computer has to be able to talk to the Arduino, and usually the drivers that the Arduino needs are built into Windows. And so the way to test it is you come up to the very top and you see it says you got File, Edit, Sketch. What you want to do is go to Tools, yeah?
If it says I should download driver, should I?
Yeah. You have a Windows
Yep.
machine? Okay, it's not Linux, it's Windows?
Nope, just Windows.
Okay. Yeah, and if it doesn't work, I'll show you where to get the drivers. So whenever we talk to the Arduino, we need to identify two important pieces of information to the computer to tell it which Arduino. Under Tools is where we set it up. You'll see the board type, and you want to make sure it's the one we're using is an Uno. There are 50 different Arduinos out there, all that speak this IDE, and we want the Arduino Uno. And I have mine listed under the Arduino AVR boards, and here's Uno. So make sure you have the Arduino Uno selected. That should be default. And then the second piece of information, you need to know which COM port's it on. I only have one COM port that I'm using, and it's COM port 11, and that's where the Arduino is. So if you're there, then the last step is when you open up that blank sketch, there's nothing in it, just the default setting. We've set the tools to talk to the board and the COM port, and now you're going to push that little arrow, and that arrow is the upload. Take the program on your computer and upload it to the little Arduino. And if you can do that, and it'll say thinking is compiling. And why does it take so long to compile? There's nothing in there. Okay, now it's uploading, done. And if you got to that point, 90% of the work is done. Anybody at that point? Okay, you don't have the right board?
What are we looking for?
The Uno, Arduino Uno. No, you don't want to touch that. all you want is board, Arduino Uno, and COM port. It's the only thing you want to touch.
Oh, you'll just need to open this.
Yeah, it helps if you plug the microcontroller in. That is an
That would make
essential
sense.
step. I forgot to tell you that one.
It doesn't just automatically upload the code?
No, not yet,
Dang.
not yet. So anybody get here? Uploaded their blank sketch?
So.
There you go.
Well, actually, that is it.
Thanks for your help. Thank you.
Yeah, sorry. Hey, what's up?
Do we have micro USB cables?
Same question, right?
Yeah. No, I need a USB type of cable now. Micro. Yeah. I have the USB-C part. I guess it's and then this one's micro too.
Oh, dear.
All three of them. Yeah, I guess we both got different problems. Yeah, I know. I can't looking for work. I got to set up.
Oh, thank you.
Sorry, do we know how to do? I need your help for a second. I'm trying to change the board, and it's not. It's straight out.
Yeah, that needs to have the driver. Let's see. Okay, so here's your key. First up, turn this on. Turn the close the Arduino ID.
Yes.
Oh,
And is it fully closed? Okay.
Now it's like, no, I'm not gonna plug this. It should be though. The manager has to do that. So what do I do then?
Yeah, that's fine. Okay, now open up the ID again.
I'm gonna go.
I don't want to burn it. That'd be a problem.
And the next thing.
Oh, there it is.
Okay, you're in.
Sweet.
You guys in? Okay, upload a blank sketch. So if you can upload, you got your computer talking to the Arduino. That's fantastic. Now we're ready to run some code. And the very first thing we're going to do is, so if you're not familiar with the code, you think, well, how do you get started? I mean, how do you know what the programming language is? I'm going to show you a cheat sheet, which is basically everything you need to know about the programming language. If you go to help and you go to reference, it brings up an internal web page that is the language reference. And this has all of the commands that you're ever going to need. And that's it. And it's all hyperlinked. So if you care about one of them, you can click on it. Like we're going to use the digital write command in a minute. And if you click on it, it opens up the page, says it'll write a high or low value to a digital pin. And we're going to use the digital pins to drive the LEDs. So that's the command. And so that's where you find all the commands. So if you ever want to go back to it, that's where you find them. So we are going to, like I said, instead of writing a lot of code, we're just going to grab stuff that's already there. I usually say we're going to steal some code, but I think the official term, we're going to use code reuse that's available. So we get a file and examples. And the very first one we're going to bring up, because the first example we're going to do is we're going to just drive some LEDs. We're going to turn them off and on. So the very first example we're going to do is under basic, and it says blink. And blink is the fundamental first. It's like, what do you do if you get a new computer? What's the first code or program that you write? What is it? Hello world, right. If you have a microprocessor, it's a computer, then it's just standalone. It's just going to do information processing, display, type, keyboard, mouse, display. And so you're going to write, you're going to display hello world on the monitor. But a microcontroller is a lot more than a not as powerful, but it does more. It interfaces with the physical world. We sometimes call it physical computing. And so instead of typing hello world and seeing it on the console, we're going to give it a heartbeat. And that heartbeat is having it blink an LED. And so we're going to start with the program called Blink. So you get that from File, Examples, Basic, and then Blink. And I think it's well, we're going to modify this. Everything that's gray, you see all these things here, it's all gray. These are all comments. They're just in there. You can add anything you want. You can even add URLs that are hot linked in the comment field. The colors, the words that are colored are keywords. These are commands. And every program has a setup loop and it has a loop. And the setup is run once, the loop is run over and over and over again. And so everybody should see this blink. And we are literally going to just run blink. And here's what it's going to do. In the setup, we're going to create, this is a variable name, LED built-in, that all Arduinos understand. And this is the pin number. So on your Arduino, if you look at it, you got 2 rows of pins on opposite sides. One of those rows has a whole bunch of numbers. It starts at SCL, and then it ends at 1, and you can see 13, 12, 11, all the way down to 0. Those are the digital pins. Each one of those can be controlled by its pin number. That's how it's identified, and it's written right on there. And so we can select which pin we want to turn high or low. And in digital world, it's high or low, but in the analog world we live in, it's an output voltage. What is a low signal? How many volts is low? So we're going to have a low and a high. How many volts is an output low? What would you guess? It's how low can you go? 0, right? It's ground. It's going to be 0 volts coming out. So a low is 0 volts coming out pin, and a high is how many? This is where it's subtle because, It's very subtle because how do you know what the highest voltage an Arduino can output? Well, it's plugged into your USB port, and it's drawing 5 volts from your computer. It's being powered by your computer right now. And your USB port is a 5-volt power supply. And so the highest voltage you can output is 5 volts. And so a low is 0 volts, and a high is 5 volts. And so we are going to control the output pin, a voltage on the output pin, by our commands of high and a low. And to tell the Arduino which pin do we want to control, each one has a pin number. Well, where you see pin LED built in, you're going to change that to pin 13. Whenever you see LED built in, you're going to change it to pin 13. And we're going to turn pin 13 off and on, and we're going to change its brightness. And so the first line under setup pin mode is telling the little microcontroller, hey, pin 13, that's going to be an output. Get ready for some commands on the output. And there are only 2 things we can do to a digital pin. What are the 2 things we can do to a digital pin? Make it high and low, exactly. We can turn the output low or the output high. And the way we tell the Arduino, hey, that pin, I want it to be high, or that pin, I want it to be low, is the digital write command. Now, if you ever get confused, what do these things do? If you move your cursor in that word, so the cursor's in the word, and you right mouse click, you'll see down here it says find and reference. It'll pull up the reference page for that command. So that's a way of, here's the pin mode command. So that's one of the ways of getting more information about a command if you forget what it does. So that's going to set, it's telling the Arduino, hey, pin 13, get ready because we're going to make that an output, either a high or a low. And then here in the loop is, we're going to make it a digital write says, turn pin 13 high And what does that mean in terms of voltage? 5 volts. And then delay means just sit there, twiddle your thumbs and wait for this many milliseconds. And I said, wait for 1,000 milliseconds. How long is that? 1 second. And you'll see you quickly lose patience waiting that long. So this is going to be turn high, wait a second, just sit there, do nothing. And then what's this command telling us to do? Turn it off. And so it's going to turn off. And then we wait. And then, so here you see a bracket here and a bracket here. And one of my buddies that I learned Arduino from, he said, those brackets are kind of like hamburger buns. And they're holding all the good stuff between them. And so between the first bun here and the last bun here is all the good stuff. And everything in here is going to loop over and over and over again. And so it's going to turn that pin on, wait a second, turn it off, wait a second, come back and do it all over again. So it's going to flash the LED. And so you all are going to flash an LED. So how many of you don't have an LED? Okay, we're going to get you an LED. It doesn't matter what color you use. You can go back and find another color. I don't even know what color these are. Who needs one? Who needs one? Need one? Who else needs one? Y'all got one? Okay, good deal. So here's the deal with an LED. So what's LED stand for?
Light emitting.
Wait a minute. There are 2 leads on it, and that, huh?
What did he say?
He said light emitting diode.
Oh.
So-
I moved them in the service for it.
So it's gonna emit light when we put current through it. And there are 2 wires, but the key word in there, well, okay, light is a key word, but the other key word is diode. That means current's only gonna go one direction. And that means when you plug it in, you have to be sure of the right direction. If you put it in the wrong direction, it's not gonna blow up. It just means it's not gonna turn on. And so, okay, you have to take out and flip it over. And so if you don't wanna worry about which direction, just try one. If you wanna worry about it, you'll see that there's a long leg and a short leg. The long leg is the higher voltage, longer, higher, and the short leg is the low voltage. And so we're going to connect this, we're going to connect it between pin 13 and ground. Now we're going to do something that if you read every Arduino booklet out there, an online website, it's going to tell you never do this. We're going to do it anyway because this is a hackathon. And hacking means we're going to push the limits. What you never want to do is connect the long leg into the +5 volt power supply, and then the short leg into ground, then it will go poof. And it may be spectacular. You can try it if you want to.
Wait, really?
But you should wear safety glasses. If you're gonna do it,
We
you
have
blow
safety
stuff
glasses.
up, you have to wear safety glasses.
What if we just cover our eyes?
Or stand away, or watch someone else
I mean,
that's
I
doing it.
see the light through my
So
fingers.
you want to put it between the, it won't blow up if you put it between pin 13 and ground, but there is on the board, there's a +5 volt to ground. If you plug it in there, it'll go poof. But we're gonna do it safely in pin 13. So you want to do that? You want me to do it? Should I do it? I'm gonna do it on my board. So I'm gonna go between power and ground, 5 volts and ground. Oh, you know what? Look at that. It's working and it's really bright, but I think it's going to die very quickly because it's getting hot. Oh, that's pretty good. Hey, this one survived. That's why we do a hackathon, is to try these things. You shouldn't.
I'm not sure if it's showing.
Oh, you know what? I didn't put I had my
Did you
camera.
Oh,
Did I turn the camera off?
oh.
Wait, that's normal.
Let's try the camera again. I don't know what happened to it.
It's just running
Oh,
like
it's
in
the background.
Yeah.
Oh, okay, there it is. Okay, so, but if you put it in 5 volts power and ground, it'll just stay on, and you know, that's no fun. It's not doing anything. So we're gonna put it between pin 13 and ground. And next to pin 13, there's a pin adjacent to this says ground. So the long pin goes into 13 and the short pin goes into ground.
To put more LEDs, we can't just stick them all on the ground. So do we just put them in?
Oh, very good. Yes, you're absolutely right. So let's see. So we have to upload Blink, modified Blink. So what we're going to do is we're going to fake the pin that, remember, what did we say when you tell a pin to be a, we tell the pin, oh, I have the wrong blink running. Yeah, let me run this one. Remember, we said, hey, when you tell a pin, you're going to be low, what voltage comes out? When we tell a pin, you're going to be low now, digital write low, what's the voltage on that pin? It's ground or 0, right? And so if you want to have more than one LED in your Arduino being directly driven and pulse it and change it and all that, you only have one ground pin to stick in there. And so we're going to use an adjacent pin, and we're just going to set it low all the time. And that way we can stick, 4 or 5 LEDs in there all at one time. So this is a poor person's way of making 4 bright LEDs flash. And you can program each of the pins. Right now, I have this set for, see, I didn't want to wait for a second because I'm way too impatient. And if I said, wait a second, it's just really slow. And so you're going to change that. So here it is. I just changed it to, let's see the light flashing. Here it is at a second. And I mean, that's just way too slow. Who has time for that? And so you can change the delay to anything you want. And you can see how fast can you flash it so that you can't see it flash anymore. You get it fast enough, persistence of vision, your eye integrates and it doesn't look like it's flashing all the time. And that is a speed of about 33 times a second. That's why movies are like 24, but high-res movies are like 30 frames a second because your eye integrates it. And so if you can flash this at faster than 30 times a second, then it looks like it's on all the time. It looks like it's on all the time, but it's really turning off and on. Let's see, what do I have? I have 20 milliseconds, so it's 50 hertz. Can't see it turn off and on. If I keep it on for a shorter time than it's off, but it's still flashing quickly, but it's off for a shorter fraction of the time, what's going to happen to the LED? What's it going to look like? If in this 50 milliseconds that I've got, this period, I turn it on for only a small fraction of that time, most of the time it's off, what's the LED going to look like? Not on as much. And so if I shut it down I'll flash it for only a millisecond and off for 10 milliseconds, it's only on for like 10% of the time, it's going to be 1/10 the brightness. And that's how we modulate the brightness of an LED. We can control the brightness of an LED really, really, really well by, we call this pulse width modulation. Yeah.
Does it have to do with the electrical flow?
Not so much, well, the reason it looks dimmer is because your eye integrates, it doesn't see it flashing. The reason it's dimmer is because we have it on full blast, but only for a millisecond. It's on for that millisecond. If we could capture it in a camera or something, we would see it just as bright as when it was on before, but it's only lasting for a millisecond. It is strobing. And we can even turn it on for as short as about 5 microseconds. It's not going to be very bright because it's only for 5 microseconds, but we can make really fast. There you go. And if you move it around, you can see the individual flashes. And so here's the trick. You're driving around at night. Don't do this while you're driving. You sit in the passenger seat. You drive around at night and you look at cars ahead of you, look at their backlights, and you move your eyes really fast. And you'll see sometimes they are dots because they're using pulse width modulation to control the brightness of the lights. And so this one here, if you move your eye around really fast, you can see the individual pulse that your eye is integrating if you just stare at it at one time. Yeah. Yes. Yes, and in fact, the fairy lights that we have here, these programs, are almost a slightly brighter version of that is what you can use for your Christmas lights. You can tell a whole story, you can modulate it with sound. So now that you've got this, so now you can make a couple of LED lights turn off and on and change their brightness, and we got plenty of LEDs and we have fun with that. Second example, the second event is the fairy lights. So you know what we'll do? This is going to require a little bit of hacking and a little bit of soldering. So I'm thinking, I don't know that we have time for everybody to do it, but afterwards, if you want to, you can do it. So I'm going to show you what you're going to do. These fairy lights are in strings, and it's like 100 of them or something like that. Each one of these is. So you want to decide how many of these lights you want for your application. And they're really flexible, so you can move them all around. And so you can literally just cut the ends off to whatever length you want. Now, I'm going to show you where you can get more information about it. These fairy lights, we got these from SparkFun. Kat got them from SparkFun, but they're also available from Adafruit. She did it. It's all her. They're also available from Adafruit. And in this particular case, I think Adafruit has better documentation than SparkFun about this. And so what you're going to do is you're going to go to, let's see if we can do it here. If you want to find out information about this, you're going to go to Adafruit. How many of you are familiar with Adafruit? Oh my gosh. If you're going to do any kind of hacking and building stuff and you want to do electronics and really cool stuff, you got to know Adafruit. They're like SparkFun. How many of you know SparkFun? Ooh, more of you should know about SparkFun too. They're up the road. They got started by Nate Seidel, that was a undergraduate. Did he graduate?
I think
He did?
alumni, right?
Okay, yeah. He came close to not graduating. Junior year, he started this distribution business to distribute parts. And he tells her he used to go dumpster diving for boxes to ship to his customers, and literally in a dorm room, and it grew and expanded. And I guess he did graduate. And then after he graduated, he started SparkFun, and they were distributing these kinds of cool parts, and then they started building their own. They have a big factory over on the Diagonal in Niwot. So it's a great CU success story. And so, hey, look at all these red boxes that you see around here. They're all from SparkFun. They have a lot of cool stuff. Adafruit, same thing. The gal that started Adafruit came from the MIT Media Lab, and she did the same thing. She started up a business to do exactly that. Very cool website. So you go to Adafruit, you search Adafruit, and these are called fairy lights. And here is the Adafruit.com. Here are the fairy lights. And so here's their example of it. And you can read that. That's really good. And then here is, they have the best. So these are a type of LED called a NeoPixel. And the LEDs that we were just playing with that had the two wires coming out, they're dumb LEDs. They just do one thing. They turn on, they turn off, one color. These LEDs are smart. On each one of these little nodes are 3 LEDs. There's a red, green, and a blue, and they're digitally addressed. And so you can tell each LED how bright the red, how bright the green, how bright the blue, make any color out of it. And they're in a sequence, and they know when they communicate, when you send a digital signal, they know which order they are in the sequence. And so you can program each one individually and turn them all on or off sequentially if you want to. They're called NeoPixels because they're smart pixels. And so if you go to the fairy lights, here's the example of, and look, it's animated, it's changing color. Every one can be independently colored. And so if you go to the bottom here, they have this really great guide for NeoPixels. And so we're gonna click that. You can read about it here. You can go through and find out all the details. It's really cool. But to program them, here's what we're gonna do. We're gonna come over here to software. And, oh wait, you know what? I need to tell you about how to wire these up. These are really hard to wire up. Well, I shouldn't say, very subtle to wire up. So let's go back to the fairy light page. Let's see. So this describes the lights, the fairy lights. This describes what they are. And see, where did I see the fairy light stuff? Oh, okay. Let's go to we'll go to the bottom here, back to where we were, the Uber guide. And then let's look for basic connections. Here we go. And describes the different kinds of LEDs that are out there. Let's see, and then best practices. So you can browse through here at your leisure. Powering the NeoPixels. Here we go. And so there are a whole bunch of different kinds of these NeoPixel strips, and you can power them in different ways. And you don't have to worry about any of this stuff. It's okay if you blow things up. Just wear safety glasses. And here are the different kinds of LEDs. We're going to drive them with 5 volts so that we can get them nice and bright. I was looking for the particular thing here. Let me do fairy. Search on fairy lights. Let me find it here. Here we go. Okay, so where did I get this from? Oh, this is the description of the fairy lights themselves. Okay. Here are the strips. Okay, let's see. Power supply. Suggest this. Okay, well, I'm just gonna have to tell you how to do it. So on these little strips, in fact, I'm gonna give you each a couple of these so that you can see what's going on. See what's going on there. There's a couple of you. So we have these. Okay. Yeah, every 2. Every in the middle. However many we use. So here's.
Yeah.
So you're gonna do. Notice we have 3 wires coming off of the ends, right? And if you look at these little LEDs, if you look closely, one side has 3 colors on them. Doesn't matter, they're going to change color. The other side is kind of a frosted coating and it's a dome. But if you look closely, there's a tiny little dot. Tiny little dot is on one end. That's the key to tell you what these 3 wires do. These 3 wires have 3 different functions. So look at the dot, hold the LED array so you can see the dot, and then on the right-hand side, here's the order. The bottom is ground, the top is 5-volt power, and the middle is the digital signal going in. And so when we,
Which side should the dot be on the top of the bottom?
Oh, I'm sorry, put it on the bottom. Sorry, I should emphasize that. Yeah, so you hold it so the dot's on the bottom, and the 3 wires on the right-hand side. The bottom is ground, the top is 5 volts, and the center is the digital signal that's going to send information to tell each of these LEDs what to do. You all see that? So my eyes aren't. You see that little tiny dot there? Yeah. It's either a red or a green dot. Do you have a green dot there? There you go, a green dot. There you go. So to tell the order of the wires, you find that dot. It should be in the bottom right-hand side. It's ground, 5 volts, and data going in. That's it. The only problem is these wires are special wires. It's hard to tell, but they're coated with a really thin polymer to keep them insulated so that you notice they're really close to each other in the bundle. You don't want them, if they're touching, you don't want them to short. And so they have a very thin insulation on them. We need to wire these little wires. and we can't solder when there's that thin plastic on the outside. And so you have to scrape it off. So you need a penknife, you need a razor blade, you need something sharp to scrape off. Your fingernails aren't sharp enough to scrape off that plastic. And so the first thing that you're going to do is you're going to take the ends you've identified as you got 5 volts data and ground. You're going to scrape off like 1/4 of an inch of the plastic on the end, and then you're going to solder them into these header pins. And once they're soldered in the header pins, now you can insert them into the solderless breadboard. So we don't have time to do it now because we're only got like 10 minutes left here. But if you want to use one of these, that's the first step, and it's the only hard step. Because once you've got the wires soldered into these header pins, you can shove the header pins in the solderless breadboard and you make great connections. And that's what I've done over here. And let's see if we have a picture of it. So these are header pins. These are Honeywell center pins. And what you're going to do is you're going to break off 3 pins in a row and then solder the 3 wires to the pins. And now you've got nice secure pins to shove into the solderless breadboard. So you can pick up 3 of these if you want to use these fairy lights. You strip off the insulation on the outside edge and solder it to the 3 header pins. And then to shove into the solderless breadboard.
Oh, really?
That, or you can use the edge of the scissors, you just kind of scrape across it. So you use a penknife, with a sharp edge. So that's going to be the first step. And that's what I've done. And here's how you're going to do the connections. Remember, we said there are only 3 connections. And it's really important, ironically enough, which end you connect to matters. Because the data is going to flow in one direction. And that's why I say hold the LED with the little dot at the bottom, and the right-hand side is the data going in. Data is only going to flow in the one direction. And so you have to be really careful of identifying which the beginning is. The end can just sit there and do whatever it wants. You're not going to touch it. It's the beginning you have to be careful about. That's what we're going to solder in. And so when I finish here, if you want to use these, that's going to be your first step. The 3 connections are really easy because what's the bottom pin going to go to? Ground. And what's the top pin going to go to? 5 volts. And gosh, on the we're going to use the Arduino to power those LEDs. And so we're going to go from the there's a ground pin on the Arduino board. We're going to go from ground to the ground wire, and we're going to go 5 volt to the 5 volt. And then the center pin, the last pin, that's going to be a data pin. Which one do you use? I mean, you got 13 of them on the Arduino. Which one should you use? What's the answer? Any one you want. I'm going to show you now. Once you have, and so that's as simple as that. You get 3 pins, ground, 5 volts, and then a digital pin. Let's see. So I've got this connected in. Let's see. There's ground. Here's my ground wire. I'm going to connect this into the ground on my Arduino board. So you just have to find a ground connection on the Arduino board. Let's see, I have 5 volts. That's this guy here. And 5 volts going in. And I need digital. And so I'm going to plug it into pin 6, just picking it at random. Once we've done that, here's the second thing we're going to do. That's the hardware part. That's the hacking part. Now comes the software. So again, we're not going to write any code. We're going to steal, no, we're going to code reuse it from Adafruit. And so again, I'm just going to show you where you get the information. Here's that the fairy lights over here. Here's the tutorial showing the power usage and the wiring and all that stuff. And then here is, let's see, software. And here's how you install the Arduino library. And I'm going to show you how to do that. It's really, really simple. It's described here, so you can walk through it when you want to, but I'm going to walk you through in words. Remember when we, I'm going to open up a blank sketch here. Remember when we started the Arduino, here's our blank sketch. Here's a new sketch. Here's a blank sketch, nothing in there. We selected tools and we selected the board that we got and the COM port. Right next to it, there's a menu item called sketch. That's the code that we're writing. And if you scroll down, you'll see there's include library. We're going to download a library from Adafruit that has all of the special code to drive these NeoPixels. And so we go to include library, and there's a tagline that says manage libraries. And it's going to open up, and these are all the different libraries that are available for all the special devices that you want to drive. It dramatically simplifies the programming, which we're not going to do any. But there's so many of them. Look at there are a gazillion of them. How do you find the one you want? And so we're going to look for one here. We're going to type in, this is going to be Adafruit NeoPixel. And this is all described in the website over here. You're going to Adafruit NeoPixel. It's all described in there. We search for it and we say, okay, go find me something that's Adafruit NeoPixel. And we're going to look for the one that, here it is. These are fake, they'll fake you out. Adafruit, something else with NeoPixel, Neo Matrix, Neo something or other. Here's the one, Adafruit NeoPixel. And that's the one by Adafruit. And that's the one we're going to install. I already have it installed, so I have it installed. You'll have a button here. Hey, you want to install it? Yes, you want to install it. It'll take 30 seconds to install it. So everybody get to that point? You'll find it? Installed it? Okay, it is essential to have this because it dramatically simplifies how to drive the LED strip. So anybody have it installed already? Nobody's there, everybody's waiting for other things? Yeah, all got it? Okay. Now that it's installed, we're gonna grab an example. So we go to File, Examples, and this is where, at your leisure, you can explore some of these. We're gonna scroll way down here. We're gonna look for something that says Adafruit NeoPixel. There it is. And here are all the examples they've already created. We're just gonna use strand tests. Really, really simple. Here's that example. And you can read some of the details, da-da, da-da, da-da. Here's, it's gonna use that Adafruit library we just installed. It's gonna do some things here. And here is where we're gonna do the first thing. We're gonna start talking to the NeoPixel array, and you're gonna keep this exactly the same, make no changes. You'll notice here it says Neo, you have a green, red, and blue LED NeoPixel. So everything is perfect. Everything's gonna stay the same, da-da, da-da, da-da. It's gonna stay the same, da-da, da-da, da-da. And now, let's see, where did I passed it? Here we go. We need to tell the software which digital pin did we plug the LED string into. And for me, I plugged it into pin 6. And so I would come here and LED pin 6. If it's pin 11, you type in 11 here. So that's where you pick whichever pin you want to drive the LEDs. You just have to make note of it and tell the software, I'm using this pin. And the second thing you have to tell it is how many LEDs do you have in your string? And you could probably drive at least 20 or 30 if you wanted that many for your project. In my strip, I have 1, 2, 3, 4. And so I'm going to change this to 4 LEDs. That's it. And then there are some routines that it's running. These are standard commands. It's going to initialize it. It's going to turn them on. This sets the brightness. And this is, how do we set the brightness of an LED? That's how we turn it on and off.
You change the delay.
The duty cycle, right. It's in the delay. And all of these are turned off and on with pulse width modulation, all happening automatically. And so when we address each LED, we're going to tell it how much of a red up to 256 or 255, how much of a blue, how much of a green, 255, and it'll go up to that full amount. Well, we can turn all of them, we can scale that brightness by another factor of 256. And right now the brightness is set for 50. That's 50 out of 250, that's only 20% brightness. No, yeah, 20% brightness. I don't know about you guys, but hey, this is a hackathon. We're gonna push things to the limit. We're gonna make it 250. So that's going to be as bright, almost as bright as they can be. So that's our scaling factor. We can still make every LED really, really dim by just setting its value of 0 to 0 or 2 or 3. So we're going to set the brightness, and then we're going to run these routines. And I'm not going to go through the details. You can look at them. These are standard fixed routines. You can play with them. Look, Here's the loop command. That means everything in here until here's the beginning of the hamburger bun. Here's the end of it. Everything in here is going to be looped over and over and over again. And these are going to be different patterns. So we're going to do this color white pattern, this theater chase pattern, this rainbow pattern. And if you only want one, I'm going to show you the trick. If you want to comment out and not run something, what's the command to do that? What symbol do you use to comment a line? It's a double slash. And so this double slash has commented this line out. And so I'm going to comment these two here initially. I'm going to comment that and that and that and that and that. So the only thing that's going to run is this, the color white. And so we're literally just going to run it, upload. Now I'm doing it here. I have mine connected. If this is something we're going to play with, you're going to solder the wires together, put it in a header pin, connect it this way, and you're going to have yours running. And there are my colors running. Let's see, can you all see that? That's what this particular pattern, oh, you can't see the camera. That's what this particular pattern was set up to do. There you go. And so it's just running through some basic colors, one after the other. So that is the color white pattern. And let's see, what else can we do? So that was that pattern. Now I'm going to comment these out. I'm going to turn the theater one on. Let's see what that does. And I'm going to upload it. So every time you make a change, you have to upload it to the microcontroller, and it's sending, all it's literally doing is sending that one digital signal out in different patterns. And hey, there's the theater chase. Oh, you can't see it, can you? I have to get my camera. There we go. And so it's zipping up and down, changing colors along the way. That's a different pattern. And then lastly, let's get the last pattern. There are patterns here. Here we go. Let's see. So blank strand test. Here we go. Let's grab this one. And so let's do the rainbow as the last one. And these guys, upload those. So now, here we go. And so it's a fading, oh, you can't see that. It's a fading in and out of all the different colors coming out. So these are fixed patterns. If you go through the examples, you'll find some other fixed patterns that you can play with. Again, it's the file, examples, and then you grab the Adafruit NeoPixel, and you can try some of these others, and they all work exactly the same way. Okay, so that's all the time we've got. You guys can grab, if you want to play with some of these, grab an Arduino, grab whatever length of strip that you want for the fairy lights. We didn't talk about the other one. It's a little more complicated because it requires some MOSFETs. The fairy light's really, really easy. The hard part is just soldering the 3 ends to the header pins to shove into the solderless breadboard, and then connect the power, ground, and digital pin to get them running. Okay, questions? So you guys are armed with everything you need to go make some pretty colors and flash them off and on.
Thank you so much.
Okay. So first of all, you guys deserve a lot of credit, because when I walked the floor down there, it looked like a codathon to me instead of a hackathon. So you guys are brave enough to consider doing some hardware projects. So that's great. There's plenty of hardware stuff over there to try to hack some things together with. Oh, thank you for remembering.
Thank you so much.
Okay. So help yourself. Try playing around. And I showed you the websites you can go to in order to get more information. And time to hack.
Thank you.
Bye-bye.
Thank you.
You guys are welcome to hang out.
Hey, how many are juniors? Any juniors here? Any of you in double E? Oh, okay, never mind. Because if you are, I'll get you next year in my capstone class.
Yeah.
In the 20-degree weather?
Yeah.
In the below freezing?
I'll just like put on a jacket, maybe two jackets.
Hey, you're welcome. Glad you could join us here.
It'll be like. Yeah.